What's in the water?
Flowers and the part of the moon that isn't in the sky tonight. Patrick Rothfuss. Hello, dear friends. In today's video, we would like to tell you about the presence of water on the moon, ongoing research, and recent discoveries by scientists. Before we begin, we would like to ask you to subscribe to our channel and hit the notification bell so you don't miss out on new and exciting videos about space and the universe. Now, get comfortable and let's get started. Until the mid-20th century, scientists were convinced that there was no water on the moon. They carefully observed the satellite through telescopes and couldn't find any lakes or clouds on it. But everything changed in the second half of the 20th century when NASA, in collaboration with Soviet scientists, announced that there is indeed water on the moon, although not in liquid form, but as ice. In 2018, American scientists were even able to find signs of water on the sunlit side of the satellite. This news is considered very important for the scientific community. But why has this topic become so widely discussed? And how did scientists discover traces of water on the moon if they haven't been there since 1969? Let's find out together. More than 50 years ago, the first humans visited the moon. Astronauts from 6 American expeditions, part of the Apollo program, brought back over 380 kilograms of lunar soil to Earth. The analysis of the samples seemed to indicate the presence of some amount of water in them, but this result was considered doubtful because the containers had become depressurized and water could have formed in them in Earth's atmosphere. The first real results of finding water in lunar craters appeared in 1976 when the Soviet interplanetary station Luna 24 conducted research on the surface of the Earth's satellite. During a thorough examination of lunar soil samples brought back to Earth, scientists were able to find compelling evidence of water's presence in it and confirmed the initial results of the analysis of the Apollo samples. In 1998, the American spacecraft Lunar Prospector transmitted data to Earth about the presence of ice in the polar regions of the moon. According to the instrument readings, there is most likely no continuous icy covering near the lunar poles, but frozen water may be present in the lunar soil. To verify this information, on the 31st of July 1998, towards the end of its mission, the Lunar Prospector, under the command from Earth, crashed into one of the deep craters near the South Pole. Scientists hoped to detect water vapor in the spectrum of particles ejected after the impact, but the experiment was unsuccessful and water was not found at that time. However, scientists did not give up and decided to repeat their experiment after 10 years. On the 9th of October 2009, the artificial satellite lcross left Earth's orbit and headed towards the moon, targeting the Cabus crater with a diameter of 98 kilometers and a depth of 4 kilometers, located approximately 100 kilometers from the South Pole and virtually never illuminated by the sun. At the beginning, the bottom of the crater was hit by the first bomb, which was the spent stage Centaur of the Atlas V rocket. Approximately 4 minutes later, the second bomb fell in the same place. It turned out to be the actual satellite lcross, which, before its descent, passed through the dust cloud raised by Centaur, managing to take the necessary measurements before shutting down. The cloud contained dust not only from the surface of the crater floor, but also from depths of several tens of meters. As a result of the experiment, scientists concluded that the particle cloud contained no less than 100 kilograms of water, which was a significant breakthrough in the study of this issue. Since May 2010, at an altitude of 13 kilometers above the Earth's surface, the stratospheric observatory SOFIA has been occasionally flying. It is a joint project of NASA and the German Aerospace Center. Essentially, it's a telescope mounted aboard a Boeing 747 aircraft. The aircraft reaches a sufficient altitude to avoid interference from atmospheric water vapor, allowing scientists to obtain equally precise data about celestial objects as space telescopes. The equipment installed alongside the telescope is designed to monitor the birth and death of stars, the formation of star systems, and the study of celestial objects within the solar system. The discovery of water on the moon was aided by infrared spectroscopy technology. This term refers to passing infrared radiation through various substances. When the radiation passes through them, molecules and their individual fragments begin to undergo vibrational movements. By studying these changes, scientists can identify which substance the rays passed through. In August 2018, the Stratospheric Observatory SOFIA scanned the sunlit side of the Moon, and during this process, scientists found clear signs of the presence of water. These observations initially seemed illogical. Water should not survive in such harsh conditions. After all, the daytime temperature on the surface of our satellite reaches 127 degrees Celsius. This raises questions about how volatile substances like water vapor can exist in airless bodies. There are no definitive answers to these questions yet, but there is a hypothesis that water molecules may be trapped in bubbles of lunar glass or in the voids between soil grains on the surface, shielding them from the sun's intense heat. The actual water was found in the Clavius crater, located in the southern latitudes, and in the so-called Mare references not far from the equator. However, there is not a large amount of water there. By Earth standards, its quantity is extremely minuscule. In the Clavius crater, the water concentration ranges from 100 to 400 micrograms per gram of soil, which is only 1% of the water found in the Sahara. But for the Moon, even this is a remarkable discovery, especially for its sunlit side. This finding may indicate that there could be even more water on the Moon's dark side than we could have imagined. Scientists believe it is in a frozen state within cold traps. These are small depressions on the lunar surface where an extremely low temperature of around -160 degrees Celsius is constantly maintained. So why is the topic of finding water on the lunar surface so important? The search for water on our celestial neighbor is essential because there are plans to build a station there in the future. It will serve as a kind of transit point for space travelers heading to distant planets. In 2024, astronauts participating in the Artemis mission will be sent to the Moon, marking the return of Americans to the lunar surface. And afterward, there are plans to build a massive base on the Moon's surface. To construct and sustain the lives of astronauts there, water will be required. Transporting it from Earth would be expensive, but if a natural water source is discovered on the Moon, space agencies can save a lot of money. Moreover, this would leave more space on spacecraft for delivering scientific equipment. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel so you don't miss out on new exciting videos. Feel free to leave comments about what you'd like to learn about in the next video. Thank you, and see you next time.